Okay, I think we are ready, gentlemen. You think we should take off? Well, I
Okay,
use
you're on.
the starting pistol. Good morning, unless it's afternoon or evening when we're out watching the sky. Welcome, everybody, to the SBAU Astro Hour. My name's Ronnie Herron, your proud master of ceremonies, proud to be associated with this long-time incredible club, Southern California's Astrophysics Get-Together Gang, your Santa Barbara Astronomical Unit, which I like to say is 93 million miles of fun in the sun, except, as I said, we meet mostly at night. The gents on the screen with me on the Zoom screen have been meeting here with us together on Monday mornings for over 4 years, and we just love this science. We love to kick it around, and I tell you, I'm proud to be part of the group. Santa Barbara Museum of Natural History is where we meet like this Friday, actually this Saturday. We're out there all the time. I'll talk to our outreach guy here in a minute. This week we're going to talk about a very, very large constellation. It is relatively bright and it's Corona Borealis, set to flare up, I guess. Three famous constellations soar overhead during summer months. One's a swan, one's an eagle, the other, a third is a harp we'll talk about. Summer Triangle is an asterism. We've covered Christmas trees and dragons and fireworks and crab, Mexican hat, and now it's time for a sausage. It's long overdue. A similar globular cluster, NGC 2808, we'll talk about. Saturn and Neptune are set to pass each other this week. Moon's south pole is on our radar again. And what the heck are neutrinos? I've always wondered. We're going to talk about it on the SBAU Astro Hour. Let's meet the gang. Commander of the starship is our beloved President Jerry Wilson. Hello, Jer.
Hello, good morning, and good morning, Joyce and Riley, my grandson in Oregon.
And good morning to your lovely wife, who's such a sweet lady, Pat Forgy. She has nothing but good things to say about me, just compliments me all the time. I love her. Your co-pilot for the Starship Astro Hour is our incredible captain of outreach, Chuck McPartland, sitting proudly in front of the Ukraine. You're going to be in front of that flag for a long time, it looks like.
Yeah.
And if they ever lose, I don't expect a Russian one to go up there. But anyway, he's married to a Pat, hardworking, successful merchandise manager for the club, SBAU, as well as our treasurer this week. Also joining us on stage is our navigator, Tim Crawford.
Yeah.
Yeah, longtime member, lens expert. What else can we say about you? You're retired what? Retired from, you told me, I think, and I
Dental
forgot.
technician. I used to make teeth.
Oh, okay. Well, you didn't work out there along R&D Row on East Hollister, did you? Or West
No,
Hollister?
no.
The other two gentlemen on the screen, I think, are veterans of that. I only got one cartoon. We do cartoons, science cartoons, or try to keep them
Oh,
scientific.
that's right. And I'm not sure that I have the cartoon that you
Well,
had.
you had real live cats a while ago. This one cartoon I got from you is a cat sitting in front of the night sky to the
Oh
back.
yeah.
It's back to us.
Yeah.
And I thought that definitely is a cat. That's how
Yeah.
cats are.
That one I got. The
Okay.
other ones I had trouble sending. I've been having trouble with my email. We changed we think we got hacked, and so we went around changing passwords, and I changed the password for my mail account on Chrome, and
Oh,
I've switched to a Gmail account, and so it doesn't load cartoons and send them out as easily.
and you can
Anyway,
remember
enough of that
this.
dithering around.
All right. I got a suggestion. If we're running out of cartoons, why don't we just repeat the best one of every week that we've saved in the can? The funniest one and
There's a
do one.
possibility of doing that. Now, this one is a little
I
polit
don't remember this. Okay. Robots
this
are
one's a little political. It's someone warning of the dangers of AI,
oh,
because
with the
people are noticing in AI, at least they claim to notice, that the thing is gravitating towards self-preservation. They give it an order to turn itself off and it refuses. So
okay, and it's got devil's horns, so that
yeah,
definitely
so
makes
this is the interface that the public has, and I have this too. I'm very impressed with even the early stage of AI. Don't
how do
expect too
you
much, but
how is
people are worried it has an evil soul.
Well, there was
what
just an article in the LA Times about how people have been using AI in some of these suicide prevention lines, and it's real easy to um, get them to override their protections against suggesting self-harm.
Oh,
So would it be fair to say all robots are AI?
No.
no.
They're not. What? So
And the
AI.
AI that we have nowadays is not really AI as I picture it. It's a very good lookup and language model.
Yeah.
It's like open the pod bay door, Hal.
Yeah, that would be not good.
Here's an asteroid coming to Earth or about to embrace Earth, and then Jupiter grabs the asteroid and keeps it from hitting us.
Reminiscent of our talk last Friday.
Yeah, it's a graphic depiction of a fact.
Yep.
Got
Yeah,
Jupiter to thank.
it can also toss stuff at us, but oh well.
Yes.
Here's Calvin and Hobbes. You want to read that, Mr. Prez?
Sometimes I think the surest sign that intelligent life exists elsewhere in the universe is that none of it has tried to contact us.
Ooh. And they're looking at a stump, a tree. Here's the cat from
Well,
hell.
it wasn't just a stump, it was a cut off tree and a pile of beer cans.
Yeah.
Oh, I see. Okay. Chuck, since you
Yeah,
got
there, see, there's the
what's
cans and there's the
okay.
stump. We're desecrating our Mother Earth.
Wow, Calvin and Hobbes. Well, it looks like you're going to keep coming up with them. Who wants to read this one? A cat owner, Chuck? You want to read this? What's the cat
Sure,
saying?
cat on the left. The universe is so unbelievably vast, and then the next frame is, and it's all mine.
They own us as pets, don't we? I wish I had one. And what is this? We're looking at now we see sedimentary rocks, guy standing there. Now sedimentary rocks see us. That's
All depends on your point of view.
that's true. You're right.
I didn't see that one.
Wrinkle. This looks like a Far Side.
A Larson.
Okay, what do we got? A dinosaur masquerading as a human wearing
Yeah,
a
it's got
long.
a human face, a human mask on. And he goes,
Okay.
why? Yes, thank you. I would like a knuckle sandwich.
Okay, gotcha, right. Oh, he landed there, so it's an alien.
Yeah.
Yeah.
This spaceship in the back. All right. Oh my God, we got a bunch of stuff. Brewster Rocket Space Guy. Is this a new one? Who wants to get through it? Good.
Our vast universe is teeming with billions of potentially habitable planets. In 1950, physicist Enrico Fermi asked, where were all the aliens? This is the satellite RU Sirius. Earth has sent messages into space hoping to get a friendly reply from an intelligent alien species, but so far nothing. I wonder why. Thank you for contacting Earth. Your call is very important to us. Please stay on the line for the next available representative. I give up.
You know,
Yeah,
Denise, I never know if you're supposed to go from the left down and then to the upper right, or you go
No,
from...
it's just like you read a page.
Oh,
it's
okay.
like comics, left to right.
Yeah.
Japanese would do it the other way, wouldn't they? Go right to left. You suppose they
I
do it
think
in
they
the
go
comic?
top to bottom.
Oh,
And Arab countries, Arabic writing is right to left.
is it really? Do you suppose they lay out their cartoons, their comics that way?
Yes, I do.
Oh, look at this. You put us on the left screen. All right, and now we're back. Oh my God. Ugly mugs are us.
What is that behind you, Jerry? Is that what's that?
M33?
Yeah,
I would like to point out real quickly before we start that
the picture I took.
we are missing two of our guys. Tom Whittemore is somewhere in the South and bids us well. Maybe he's watching us. You could probably log in on this, Tom, for crying out loud, wherever you are. And
Okay.
let's see, Bruce Murdoch, possibly taking care of his beloved wife, Bonnie. Tom's married to Maureen, and they're missed. But the four of us will have to forego it and go ahead here, gentlemen, on the Astro Hour.
Now
What do we got?
This is a representation from Astronomy Magazine of what T Corona Borealis will look like when it becomes a nova. However, the arrow is pointing to the wrong star.
Yeah.
the arrow here is pointing to this star, and T Corona Borealis is up in this region.
Yeah,
Pointed out
that is
this
weird.
morning to me by Chuck. So
Well, it
anyway,
looks
this
like
is the. Go
it
ahead.
looks the right side picture shows a little star just to the right of it, upper right.
Yeah.
Yes, this one right there. That's T Corona
Yeah.
Borealis.
I'll be danged. And that's how it looks. It suddenly becomes very visible.
That's how it will look. It will become, I think, second magnitude.
I thought it was on the star up from that.
Oh dear.
You mean this one here?
Yeah.
No, you can
Oh, no,
already
no.
see that one.
No, see, this is T. Coronae borealis upside down from how you'd normally see it. And I think Tim's right. It should be more near where the stem of the arrow is.
Down here?
Yeah.
Okay. So it
So there's
continues this
there's at
arc.
least two errors going on in this image.
Yeah, this star was not, this was a photograph, and this
Yeah.
is the same photograph with this star added, and they added it in the wrong place apparently.
Yeah.
Yeah.
Okay.
So if they want to write to me and correct me, we'll look for your email.
Yeah.
So,
It looks like our
that's the recurring nova that we're waiting for and waiting for and waiting for.
No, don't. It's in short order.
Yeah.
Now there's somebody, I think it's a Japanese astronomer that studied the rotation period of this white dwarf around the red giant that
Yeah.
causes this recurrent nova. And he thinks it'll happen either in November of this year or June of next year.
You know, Astro
what?
Deli that was with us, and he's
Okay.
not here today, but he had the same. I think he had the same prediction, Chuck.
Yeah, well, he must have read the same article.
Maybe the same article. Yeah.
who are you talking about, Tim?
That was Astro Deli, our friend from India. He's not here today, but he may show up in a bit.
Is that his name? Astro Deli?
That's what he goes by. That's his handle.
Oh,
But I don't know
okay.
his name for sure.
Is this the star that does it on my birthday? At least I was born in 46. I'm
This is
79.
from 47.
46
So-
was when it last went off. Yeah,
Oh,
Ron.
is it 46? Okay.
And it's supposed to go now on my 79th year.
It's roughly every 80 years that it goes off.
Okay, and somebody will let us know if it happens, and we'll all grab our scopes and go
Oh
outside.
yeah. You're
And
gonna
how
know
long-
for sure.
If
How
it's
long
8
will it-
years, it won't happen for a year and a half then.
Yeah.
Or no, a year from now.
Yeah.
Yeah.
But
Okay.
it's a nova which doesn't obliterate the star; it comes back.
Yeah.
No, it's a recurrent nova.
Yeah.
Interesting. Supernovas, it's over. Kilonovas, hypernovas, those are end of the star, right?
Yeah. This is a white dwarf that accretes, hydrogen on its surface, and then when the temperatures and pressures on the surface reach the thermonuclear ignition point of hydrogen, it blows up. It does not destroy the white dwarf, but that white dwarf has a mass of 1.37 solar masses, and if it reaches 1.4, that's the Chandrasekhar limit, and it'll go off in a Type 1a supernova. So that will be interesting.
Yes.
Well,
But
is
that's
this
not what's
rare?
expected to happen.
Right.
Are there other stars in the sky that do that?
Yep.
So it's not a rare thing.
Well,
Or
it's not a
just-
common thing, but it's not
Not common.
unheard of.
I think the Type 1A was considered the standard candle for a
It
while.
still is, yes.
So
And
it's
now
a
they're
white-
finding it's, well, sort of standard because there's a couple of ways you can get it to happen.
The phrase, "is this a rare thing?" is very interesting, I just thought, because there are so damn many of everything out there.
Yeah.
A tiny fraction of that is still a big number.
Yeah.
So,
This is a white dwarf as part of a binary. It has a partner
Yes.
that's bigger.
Yeah. Yeah.
And that partner gets showered every 80 years.
Probably a little bit.
it continuously showered, and it
Well,
we
builds up to a critical value after 80 years.
Yeah, the big one is showering material onto the little one, but when the little one blows up, then the big one gets showered a little too.
And we
Yeah.
can see the little one. We can't see most white dwarfs, can we?
That's right. Not naked eye anyway.
Well, they're
They're
usually
like-
surrounded by a planetary nebula.
Yeah.
Oh, I see. But they're
But
like
not
red
naked eye.
dwarfs. Yeah. All right.
Like in the Ring Nebula, you can't see it even with a smaller telescope, but something like the blinking planetary, which is really in this star chart, that one you actually can see when you look right at it. You'll see the white dwarf.
Where is the blinking nebula?
If you go to on the wing that goes up above there, okay, and the red line there, when you go up further than that, there's two stars up there, and then go up from that, there's two stars on the red line.
Oh,
That no, not those two. The one that you were on before, and then one above that. No, I'm sorry. The one there and the one above it.
Well, if it's above it, it's not on the
That one,
line.
and the one above, Jerry.
oh, but not on the
Along the
Below,
line of the
below.
wing, the one farther along the line of the wing, Jerry.
Yeah, farther along.
That
One
one and the next
farther
one
along.
farther along.
Right.
Oh,
Now
okay.
use those as a kind of a transit. You're going to look down that and go out about equidistant. From those two stars, draw a line, and then you're going to go out equidistant.
So it makes an equilateral triangle.
You're going to go down straight in line with that other star, not there.
Oh, okay,
You're
straight in
line
line.
with the other star. So start at the top one, go through that lower one, and go straight.
Ah,
And
okay.
about the same did right about in there. And so what you'd end up doing is you find there's two brighter stars that are brighter than the other stars around visually. And once you find those two brighter stars, you're very close to the planetary. And you have to kind of go in a circle until you see the greenish dot. And then in different scopes, it's in different places. But that's how to find it. It's really
Okay.
kind of a hard hop.
And folks, you heard that from our champion star hopper.
Well, I got
Tim.
an important question. Is this going to be viewable from Star Party?
Yes.
If it's
Yep,
dark
You can
enough.
see this when it happens at the museum at night. Okay.
Yeah. Now, right here, there's a planetary nebula. And right here, there's a globular cluster.
Oh,
And we're going to be looking at this globular cluster.
yeah, I never
Because
looked
this-
at that.
This globular cluster we might have acquired in a previous collision, M86,
56, yeah.
56. excuse me.
We get globular clusters with collisions.
They're
We just-
orbiting their
Many,
galactic nucleus, and the galactic nucleus merged with ours, and so they just gave up, and now orbiting our nuclear.
they call it a nucleus, not a dwarf
Yeah.
galaxy.
No, our nucleus, the nucleus of
Yeah.
our galaxy.
It's orbiting it.
Oh, okay.
This is the bright blue star that I talk about in the talking points. But this is a wide field view of it, and I picked it because it shows some nice star colors. You see a lot of red giants and a lot of white stars and a lot of red giants here, old stars.
Yeah, in your talking points, you said this is a really old.
Yes.
Huh.
So the brightest stars in M56 are about 13th magnitude, which you can just reach on a good night with a 6-inch telescope. It's the limiting magnitude of a 6-inch. So you need something like a 10 or 12 to be able to see them really well. The core of the cluster. It has a dozen known variable stars, RV Tauri, with 90-day periods, and V1 Cepheid variables with 1.510 days periods. Other variable stars are irregular or semi-regular. In 2000, a diffuse X-ray emission was tentatively identified from the vicinity of the cluster. This is most likely interstellar medium that has been heated by the passage of this cluster through our galactic halo.
Okay, Ron.
What's
Ron?
that?
Ron,
Yeah.
you were questioning the speaker who's going to talk about galactic atmospheres and rain. And that's
Yeah.
what we're talking about, is this halo of hydrogen gas that's around our galaxy that falls down into it gravitationally.
He'll be our September 5th speaker. He's a young grad student. Doesn't have his doctorate yet. His name is Ish Call. And
Yeah.
I asked him, what the heck are you talking about? And I thought it would be nebulae, but it's not. It's these things, right?
These are nebulae. They're just very diffuse.
Yeah.
Nebula just means cloud, Ron. So there's almost anything out there is practically a nebula.
Yeah, your barbecue produces a nebula.
Yeah.
I've got a few nebulas in my eyes.
Yeah.
Yeah, that too. I got one. Yeah. I've got
But
a
there's
few
also
impactors too.
he also uses the word rainfall. Where
Yeah.
do you
Well,
rainfall out there?
that's where the
That's a
hydrogen gas is falling down toward our galaxy by gravitational attraction.
yeah.
Wow, wow.
But it's not compared with oxygen to give us water
No,
droplets?
no, no, no.
Oh, okay. Fantastic.
Okay, the relative velocity of this cluster relative to our atomic or our galactic core is 177 kilometers per second. It's really whipping along, which is sufficient to heat the medium in its wake to a temperature of almost 1,000,000 degrees Kelvin.
Whoa.
M56 is thus part of the Gaia sausage, a hypothesized remains of a merged dwarf galaxy with us.
Now
So
that was
this
really interesting.
M56 was believed to be a globular cluster in the galaxy that we merged with. And so, and it's got this odd motion through it. Now, when they talk about, we're going to talk about the Gaia sausage. This is Gaia refers to a spacecraft that we put up that's orbiting, and it takes pictures and records the velocities of millions of stars in our galaxy. And the sausage is a shape that shows up in a velocity diagram. You can't see it in a spatial diagram, a picture of stars, but if you plot the transverse and radial velocities of these stars, there are two major groups of this. There's one that is believed to be the old members of our galaxy, and the sausage gives another shape, and that's believed to be the stars that were in the merged galaxy, the thing we hit.
Wow, wow.
So this is known also as the Gaia Enceladus. It's the remains of a dwarf galaxy known as the Sausage Galaxy, Gaia Enceladus. Anyway, that merged with the Milky Way about 8 to 11 billion years ago. So the Milky Way was about 2 to 6 billion years old when this occurred. Sorry, we don't have a more accurate date than that, and these are guesses. It added 8 globular clusters to the Milky Way, and along with 50 billion solar mass of stars and gas and dark matter. It was the last and most recent major merger of the Milky Way. The Gaia sausage. Go ahead.
Do you have a picture of it there that you can show? Does
We
it look
do,
like a
we do, but
sausage?
I want, yeah,
It does look like a sausage. It's a
it
big,
does,
long
yes.
pepperoni.
So
That's
it's a
not a visual
characteristic shape.
depiction, Ron. That's a depiction with, velocity relative to other things.
Yeah, see, it's in chart of velocity space, and I wanted to say that several times before we get to the picture, so you don't think we're actually showing a picture of the stars. In particular, it is a plot of radial versus azimuthal velocity. That is proper motion and radial motion, another way of saying it.
Huh.
And it was the primary mission of the Gaia spacecraft.
Which has been deactivated.
I don't know.
Yes. Yes, it has.
Okay.
Are they going to bring it back or just leave it out there orbiting?
No, you can't bring it back.
Some of them are crashing to Earth, I hear.
Yeah.
Yeah, no.
Now they gave it the name Enceladus, which sounds like a moon of Saturn.
Yeah,
It
yeah.
is, yeah.
It refers to the mythological giant Enceladus, who was buried under Mount Etna and causes earthquakes. Thus, this former galaxy was buried in the Milky Way and caused the puffing up of the thick disk. And I didn't add here, but I looked at 3 different sources and read 3 different papers, and one of them claimed that this collision and absorption was responsible for the Milky Way's bar in the center.
Mm.
Oh,
Really?
Yeah,
That's a major structure.
it is. So there's another globular cluster called NGC 2808 that is also believed to be one of the a larger globular cluster that we have from that collision. And as you see, it's in the southern sky, so we will never see it here. This is the South Pole polar sky here. And it's got a lot of interesting combinations. Mensa, the Genius Society. I think it probably means something else here.
It means table, and it's named for Table Mountain in South Africa,
Okay.
where John Herschel had his observatory.
Okay.
Mensa?
Mensa.
And here you can see the southern Milky Way going down from Crux and Vela through here. Nice, a lot of bright structure in here.
And the pole star is right in the center of that, of Octans?
They don't have a pole star like we
Oh.
do.
That's the south sky? South?
Yeah.
This is the south sky. There's
So
supposed to be a southern cross down here somewhere, but
But Crux, right up in the upper
That's
right there.
Crux, yeah.
I don't see where you're
It's
pointing.
cut off on the upper top
Oh,
part. If you
this
go to the
here?
right, go to the right.
Oh, yeah, there.
Yeah. And
Oh, I thought that
those
was the
gay
southern
crux and
cross
crux
here.
point and acrux point toward the South Pole roughly.
Okay. Got it. See, I only visited once.
Yeah. And there is a star that's pretty close to the pole down there. It's called Sigma Octantis, but it's not naked eye visible.
Okay.
Oh.
But this is what the sky would look like if we were in Antarctica.
If you stand on your head and look at this, yes.
I guess we are when we're in Antarctica. We're standing on our head compared to the way we are now. Yeah.
Would the water drain up?
Yeah.
Water drain up. This is the core of 2808. And this is believed to this is speculated by some to be the remnants of the core of the dwarf galaxy.
Oh,
it's a very large globular cluster with over 1 million stars in it. It's a very large globular and an old one.
Are there more NGCs up there than M's?
Oh, absolutely.
Oh, yeah.
Oh,
There's
about
8,000 NGCs and about 110 M's.
Now this is not 51. This is a
no.
Oh, this picture is an artist's conception from data of the merger of the Milky Way with its dwarf galaxy here.
Wow.
And they're coming together nucleus to nucleus. It's a direct.
That's what could have created the bar.
Yes, a speculation.
Yeah, but Jerry, that's fascinating.
This is a topic that they're publishing a lot of papers on. So the Gaia satellite produced a lot of data.
Yeah,
and they're mining that data.
I've never heard of any of this until your talking points.
Yeah,
I've never heard of it. It's fascinating.
No, I'd never heard about it either. I almost didn't put it in because I thought I don't see a sausage there.
Yeah.
But here's the sausage.
Oh God.
These are individual stars. This is the circular motion, or that is our transverse motion, and this is radial motion toward us, or toward the center of the galaxy. So this is around the galaxy, and this is radial motion toward the center of the galaxy. And our galactic disk is this group of velocity of stars. They each represent the star's velocity, and these are velocities for stars that form a sausage shape. And this is in velocity space again. So
now the crosses of the zeros, Jerry, what does that represent? The zeros.
See the labels down below, Tim. One is away from the center, and one is toward the center.
Uh-huh. So it's kind of the center. You're just centering it.
No, this is toward the center of the galaxy. These are stars that if you see them, they are at rest with respect to going in or out toward the center of the galaxy.
Okay.
These are over here are stars that are heading rapidly toward the center of our galaxy.
Or away on that side.
These over here are stars that are heading rapidly away from our.
No, it's just the opposite, actually. It's toward the center of the galaxy to the left.
Oh yeah, you're right. Yeah.
Same idea, though.
Yeah.
Huh.
I just looked through the wrong eye.
Yeah.
Depends on whether you're upside down or not.
Yeah.
So anyway, Gaia measured the velocities, these two velocities of 7 million stars. Now there are billions of stars in our galaxy. So I don't know how much more data it has, but still, this is a very good sample. It's not like a few stars here and there. It's statistically significant.
Yeah,
Well,
overall, it measured several billion stars.
Yeah, I think that, yeah, the data set is very large, and yet it's in progress of being explored.
you know,
Yeah.
it's just a reminder of how important it was that computers were born, because couldn't imagine some guy counting 7 million stars, and
We would have had 7 million punch cards if you were back in the IBM 730 days.
yeah.
You know,
Well, we got
computers started with a guy that was using the equivalent of IBM cards, but made out of wood to control what are those things that make cloth? Yeah.
Looms,
Looms, yeah,
Jacquard
to
looms.
control looms. Yeah.
Huh.
And he essentially invented punch cards, and they would feel the hole and then move things on the loom.
Kind of a predecessor to the hanging Chad.
Yeah.
Yeah, hanging chads. Yeah.
Or the player piano.
Oh, yeah,
Yes.
yeah,
Player
yeah,
piano's another one too. Yeah.
yeah.
well, this was named after the space telescope. The guy was only came to be with the launch of that scope, right? That's now
Well,
deactivated.
the name
Yeah,
of
this
the
data.
name of the mission was Gaia.
Yeah.
Okay, and then it was a scope, and it found this, and we
Well,
wouldn't have known it
it
was there.
wasn't a scope. It was a combination of several small scopes and rotating, and they would use the relative motion to figure out. They got really precise measurement of the positions of stars using it and motion of
Re-
stars.
repetitive parallax.
Yeah.
Huh.
But you don't know where the word GAIA came from?
Well, that's the Greek goddess. That's the goddess of
The Earth.
yeah.
Really, we had a goddess left that hadn't been put on a moon somewhere? Wow.
There
Oh, I'm
was
sure it's a
this.
moon somewhere too.
There
Oh, it
was.
is? Okay.
Okay.
Well,
You had to warn me
fascinating.
out. I got to get some coffee.
You know what sausage reminds me
I
of?
came prepared.
I got to tell you, the word sausage, it makes me miss those three pizzas that Chuck would deliver to those planning meetings. We don't get those anymore.
Oh yeah.
Sauce and mush.
Yeah, we
Yeah.
move on.
Well, without Tim, I guess he's gone to get coffee. Bruce
Okay,
and Tom.
this on August 6th at about 4 a.m., Neptune and Saturn will be in conjunction. That is, they'll be close together. Now it shows here nicely on this star chart from my computer, but you will not be able to see Neptune with your naked eye. You will need a telescope, but it will be close enough to fit in the field of view of the telescope. And I pointed out here on this thing, it uses this red thing for dwarf planets. This is the Dwarf Planet 1 series, which is also an asteroid, but it's round, and so it qualifies as a dwarf planet. Here's another dwarf planet over here, which we know as Pluto. And this is in the night sky, but in the morning, you can see the horizon is starting to get brighter on this. This is 4 a.m. on August 6th, which I think is Thursday. We're Wednesday.
Sounds right. Wednesday.
Yeah. So there's an eyeball thing. I mean, a telescope thing. Now, Saturn at that time, these are the this is the outer moons of Saturn, Iapetus, and there's Enceladus and Mimas and Tethys and Titan out here, which is the easiest to see. It actually looks red, but I have sufficiently modified my planetarium program so that the moon of Saturn named Mimas not only shows up here, but several other astronomical objects my computer now thinks is also Mimas. So if it pops up, I have to manually change it. But this is correct, this one.
Hmm.
Do they count those little shepherd moons inside the rings as regular moons of Saturn?
Yes, they're regular moons, yes. And if you look at pictures of them, There was an article I should have put in this session about the oddball moons of Saturn, because one of them is shaped like two hats stuck together. And
Dumplings, yeah.
What are
yeah.
we up to now, Chuck? 245?
274.
Oh my God,
Oh,
it's
I
up
didn't know we
again?
passed 200.
Yeah.
Well, some of them look like
That's not
walnuts.
fair because they've got an infinite supply of moons, basically. So
Yeah.
this is the same picture. This is August 6th at 4 a.m. when it's close to Neptune. This is what you'll see. This is what to look for with the moons. But Neptune will be farther away than this picture. This is the inner moons, Tethys, Hyperion, Mimas, Enceladus, and Dione.
Good job, Jerry.
Yeah, so
I couldn't have said that if I tried.
I almost didn't say it.
Well,
Okay.
which of the outer planets is turned on its side, Uranus or Neptune?
Uranus.
And so we'll never see a flat version of that ring. It's always like a bullseye or a target, isn't it? The
All
ring
the
that,
pictures I've seen are not edge on, yeah.
okay, now we're on the moon.
Now we're on the moon.
Ooh, that was
So
fast.
the moon right now is I think last night or the night before it was first quarter. So this is later this week, just before it turns full. You can see the terminator is here. So it's not illuminated all the way to the edge of the moon, but close. You can see where these objects are, these two craters down here. Schickard and
Wargenton.
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 Interestingly enough, this is a selenographic picture of it in Italian. And here
Oh, I
it's
like that chart.
Vargenton. Schickard retains its spelling. But if you look around here, familiar things, Lacus excellentia, Heinzel, Vieta. It's nice to say these things in Italian.
Don't see any Mares.
Oh, that's Lacus. Oh, well, that's just because it's a lake. If they were farther up, you'd see the word mare.
Oh, okay, got it. That's the seas, right?
Lacus is lake, but the others are seas or oceans.
I like this image, Jerry.
Yeah, it's a very nice thing. This is a processed map, you might say. It's from a photograph, but it's very well processed. Subtle shades of color are there. So it's intended to show the colors of the moon, which escape human vision. When you see the photographs of the moon from the moon, it all looks monochromatic, except for a few orange rocks and white splashes.
Monochromatic, meaning black and white.
Yeah.
Like that.
Now, this is looking straight down on Schickard from a lunar orbiter 4. And you can see that this was taken in strips and pasted together. So this is a very old mission. Matter of fact, there was a great cartoon that I can't locate anymore where it shows the first few astronauts landing on the moon, and they're standing next to the lunar module and they're looking out at the landscape of the moon, and the moon really is divided up into bands. So you can see that it's a young, this crater happened, and either when it happened, it broke through and formed with lava, or later, probably when it formed. And it wasn't too long ago because it's not as densely cratered as the surrounding terrain. Although it does have a lot of craters in here.
A lot of little ones.
Yeah, a lot of little ones.
It's washed out, but it's good enough to see. It's interesting that the washed out images, when you first
are these washed out for you?
Yeah, but when you first click on them, they're the right
oh yeah, I've run into that before.
Kind of washed out.
Yeah, it shows up initially as good contrast and balance, but then it
gives it up,
and then it pops off. So maybe something in settings, I don't know.
I know, I'm
amazed. The culprit.
I'm amazed, gentlemen, that we don't have more cartoons, or I've never seen one showing astronauts landing on the moon and doing something with Kubrick's big mammoth thing that was buried in Clavius, that the
The
monolith,
monolith.
making a phone call or banging on the door, seeing if anybody was home. You'd think that'd be great fodder for cartoons, but I haven't seen a thing.
You got to watch the beginning of Barbie.
Oh,
Yeah.
really?
Oh, is it in the Barbie movie?
Sort of. There's reference to it.
Too much pink for
Not
me.
so
I'm
much
sorry.
the monolith as the opening of 2001: A Space Odyssey.
Yeah.
Oh,
The Barbie
okay,
movie
good.
was a sleeper. It's a very good movie, but it on the face of it, it looks like it's for preteen girls.
Yeah, that's
Anyway,
what I've been thinking. Yeah.
but it's very clever. This is can you see this better? Is less
Yeah.
washed out?
Yes,
Okay.
you can.
Okay.
Now we can. Yeah.
So you can see
Let's
little
see.
patterns of craters and stuff. I think these were things I've always thought these were things flying in orbit that hit, simultaneously. This one hit a little before that one.
Big craters like this are mini Maris, aren't they?
Yeah.
They are if they fill up with lava like this one did.
Oh, that's what. Yeah, right.
And then
And hardened.
this is Wargenton, and it's got less craters, but consistent with the surrounding.
Oh, ow.
Do you suppose if we landed on that, it would be flat and not dusty?
No, I think it would be just like I think all the moon is pretty well represented by where we landed.
Because lava down here on Earth leaves fields of rocky, craggy. You ever seen lava beds?
It
There's
will,
places.
but this has been undergoing proton bombardment for billions of years and meteoroid bombardment for billions of years. It's
I'm just talking
not
about
gonna,
the flat part.
yeah, it's not going to be like Earth's volcanoes, which we only see the lava we see is relatively recent.
That's
You,
probably true. Yeah.
if you drive out to Arizona along Highway 10, off south of you can see all these odd looking mountains have really sharp shapes to it. And those are the cores, the solid cores of ancient volcanoes, where the cone, which is softer material, has been worn away by erosion. And you
Hmm.
get these craggy, almost moon-like mountains out there, except they're not moon-like because you don't get that kind of erosion on Mars. I mean, on the moon.
Huh.
Right.
Well, Hawaii. Go ahead.
Oh no, no, I was going to say in the central part of that crate of that ocean there, it looked like there was a rebound.
Hmm.
See that in the center?
You mean
It's
this mound
yeah,
there?
that mound there.
Yeah,
But it got covered by the lava and you can still see a lump.
yeah,
Huh.
that would be my guess.
What's this like a water droplet?
So this is a neutrino detector.
Oh,
Ooh,
It's
we're going to
buried,
neutrinos.
it's buried in a mine in Japan, and it's called the Super Kamiokande. Now, I was on a business flight to visit DARPA one time in the 90s, and
Visit where?
to visit DARPA, the Defense Advanced Research Projects Agency in Crystal City,
Oh,
Virginia. And a guy got in the bus. We got picked up um, by an Airbus to take us to the airport. And a guy got it. Me and another guy were in the car, and we started up a conversation because we had to go around and pick up several people. And he described this detector he's working on, and I said, "Oh, it sounds like you're working on the Super Kamiokande detector and stuff." And he goes, "Oh, you know that?" And I said, "I built part of it." And so, because we did something at Santa Barbara Research Center, these are this is a container of water, very pure water. And each one of these things around here, this is buried under in a mine way under the mountain in Japan. And it's filled with water, and these are photomultiplier tubes. They're not solid state detectors, they're tubes.
beer
And
bottles.
a what?
Beer bottles.
They're bigger than beer bottles, but yeah, but they're like that, not filled with beer.
Yeah.
a neutrino passes through here, and it will collide. There's a very low probability it hits a water molecule, and when it does, it produces a flash of light. And these photomultiplier tubes measure that flash of light, and they measure because when it hits, it measures a pair of photons, and so it correlates the photons, so it knows the angle that the photon went at, and it can figure out the energy of the photon. And from that, it can derive the direction the neutrino came from. So that's how a neutrino telescope works. And this is the
Wow.
only one I know we have. This
Uh,
shows the maintenance on the inside.
Look at that. Look at that thing floating.
Yeah, this is a life raft with two people in it, and they fill it up with water up to this point, and then they examine all the tubes at this level. They fill it up a little higher, and they service all the tubes here. It's a long process. And here it shows the size of the tube relative to a human, these photomultiplier tubes. So it's been going on for probably 30 or 35 years, doing quite successfully.
And there are other detectors like this, I think, at the mine in Colorado and also beneath Antarctica and in the Mediterranean off of France.
Yeah, the one in Antarctica is called the ice cube.
Yeah.
Huh.
And it looks like they've got cats stuck inside their photomultipliers.
Right. That's actually a reflection.
It does.
That's actually a reflection of the inside. Here's the picture of a distorted picture, and they're floating at this level.
And there are just godzillions of these neutrinos, and only one or two will hit a bottle or a tube.
Neutrinos, you have apparently the statistics, I don't remember them exactly, but it's something like 100 billion neutrinos are flowing through every square centimeter of your hand every second. I mean,
That's what I
there's a lot
said.
of them.
Yeah, okay.
They just miss us.
What is the thing that they were talking about? And I, when I say they, I don't, maybe they're opticians. We were talking when you have your eyes closed and every once in a while you see a bright flash.
Yeah,
Cosmic
that's
ray.
usually an alpha particle striking in your eye.
That's not a neutrino.
Yeah,
No.
helium
They come
nuclei.
from stars like our sun. Are they going near the speed of light?
Yes.
But most of the things that we interact with are from a cosmic ray shower. That is, the
Oh,
cosmic ray comes in and it hits the atmosphere and it produces a cascade effect. They
that's
used
not
to
all
sell
part of
they used to
it's
sell
not-
chemistry sets for kids in the 50s, and they had an alpha particle emitter. And if you got in a dark closet and you got your eye accustomed to the dark, you could hold this thing up to your eye, and you could every now and then you could see faint little flashes in your eye. And that was when alpha particles hit your eyeball, hit your retina.
Wow.
They
And
don't sell good
these
stuff like that
neutrinos,
anymore.
these neutrinos are really super hard to detect, and there's so
They
many,
are.
and they go right through everything, huh?
Yes, they do. And that's
I've-
why
I've-
the neutrino, it pictures the sun when you're looking through the earth, through the bulk of the earth, because the earth isn't there for the neutrino.
Yeah.
Yet it cuts out all the other stuff, all the cosmic rays that would interfere. So this is an image made of the sun. Now, why do you think they're interested in the sun? You
The-
all know it. You
with
all
the
know it.
with the
It takes
neutrino
30,000
study.
years. It takes 30,000 years for a photon to go from the center of the sun to the outside of the sun, and then 8 minutes for that photon to get to Earth.
Well, it takes more like 100 or 300,000 years.
I heard Tom say 100 or 300,000 years,
Yeah.
but the article I read said 30, so I'm stuck with 30.
And
Okay.
I heard
I
a
don't
billion.
know.
So
I'll accede to any opinion.
Well, it's
So,
the same story for neutrinos then, right? They're made in the
Nope,
sun.
nope. Neutrinos come direct. You see neutrino at the speed of light. So it takes a teeny bit over 8 minutes for a neutrino to get produced and to come here. So this gives you a now look at the sun's core.
huh.
The reason the photons take so long, Ronnie, is because they're constantly being absorbed and re-emitted. whereas the neutrinos don't interact at all and they just zoom out.
But they're made in the fusion of the core and then instantly go to the surface. They treat the sun just like they treat the earth. There's no big
Yeah.
deal. They can get
Yeah,
through
it's
all
not there.
Exactly. And
Wow.
neutrino detectors like this can give us early warning of a supernova before you see the visual part. Because when the explosion happens in the core, when the core collapse happens, it generates a flood of neutrinos and they come right away. But it takes time for that explosion basically to reach the surface of the star, especially if it's something like Betelgeuse, which has a huge radius. It could take 40 minutes for the explosion to reach the surface of that. And so you get an advance warning of a supernova by seeing this flood of neutrinos. And they
I,
actually saw that for the 1987 supernova in the Large Magellanic Cloud.
oh, okay.
But neutrinos come from all stars, not just our sun,
Right.
but the
Yeah,
overwhelming majority.
they're a
Majority
product
are,
of nuclear decay.
it's part of the solar wind, right?
Yes.
I also I was
We
I
don't
was
feel it.
Hmm.
I was watching one of these shows that how the universe works, and they were talking about neutrinos, and I wish I could remember what the guy was saying that neutrinos are super important for, and I'm blanking on it. I don't remember what the guy said, but studying studies like this really would help. And then I blank out. I can't remember it.
Well, part of it is because they see neutrinos. They used to think they were massless, but they see that they actually change type of neutrino as they travel. There were these various types of neutrinos that were detected, and it turns out that it can be one type fluctuating into other types.
Oh, so okay,
And so that's how they knew they had some mass.
okay.
And they also, there's neutrinos and antineutrinos, and they act a little bit differently in some reactions. And so they're looking at that really closely to try to figure out why there's matter, why there was the matter antimatter imbalance that left us with a matter universe.
Yeah.
Uh, yeah, maybe that was
Now,
it.
as Chuck mentioned, neutrinos turn into each other there, and he said there are three types of neutrinos. At first, we didn't know that, and when they counted the neutrinos they got from the sun, the amount they got was 1/3 of the number that the models predicted. And
Yeah.
that's when they found out that on the way here, the neutrinos rotated into the other two types, so you only got 1/3 of them left over.
Because
And
we were only able to detect one kind at that
that's
time.
right.
But
And
because
as they
because
got
of the
better at detecting neutrinos, there was a case in Gran Sasso, Italy, where the lab decided that neutrinos, they had experimental evidence that neutrinos uh, traveled faster than the speed of light. And it sparked one of the funniest jokes I've heard in physics was where a neutrino walks into a bar and says, "Why is it so dark in here?"
oh, okay.
Because the photons haven't got there yet.
And another one was the bartender says, "We don't serve neutrinos here," and then the neutrino walks into the bar or something like that.
So, right.
Yeah, God
Well,
help.
But it
are they
turned out
with
it was a loose wire in the experiment that gave them a misreading.
but
Oh, okay, okay.
So
but
the
because
joke,
of because of the name, they're a non-charged particle. They're not plus or minus, positive or negative. They're like a neutron, right?
yeah.
Wow.
But the debate was whether they had mass or not, and they have a very small mass.
Well, where are the anti-neutrinos? Are they in the sun too?
They're
Apparently,
produced in varied
Places
nuclear
in the
reactions.
universe, not near here, I hope.
When you take a neutron by itself and you put it out in free space, so it's not in a nucleus, it will spontaneously decay in about a half-life of around 15 minutes into a proton, an electron, and an antineutrino.
Oh, geez.
And an anti-neutrino.
Yeah, they're all over the place.
So they would only annihilate a regular neutrino. They wouldn't annihilate if they collided with a proton or a electron, assuming it's a particle.
Okay, I'm going to have to go back to the other way because that one thinks I ran out of charts.
Okay. Been a fascinating hour, Jerry.
Yeah.
Okay, this is a highlight summary. See it okay?
Yeah.
Yeah, greatest hits.
Okay. This is a highlight I found on the web. Uh, Achievements of the James Webb Telescope as of July of this year. May have directly observed black holes forming in a galaxy shaped like infinity. That's the Infinity Galaxy. We discussed that last week. These are two galaxies. There's a black hole in this galaxy and in this galaxy, and these are represented by that diagram. And there's believed to be a third one forming here due to the collision and the density of the crashing star clouds and dust.
So it's a direct collapse supernova, which we hadn't seen before.
Yeah. Astronomers discovered plenty of low mass black holes in the early universe. So this is the black hole, not these.
Yeah.
It discovered it, it saw it, or saw an accretion disk.
This is just an artist rendition.
Oh,
So they're of a black hole. The actual
These are-
discovery photograph, some of these discoveries are, I mean, we look at pretty pictures on it. It's many of our hobbies to take pretty pictures, but most of this information comes from data, not from, a picture with an arrow pointing to what it is.
And a lot of this
Are
is
these-
from distortions in the space-time, not from the actual accretion disk, just
Right.
from the way it deflects light.
Mhm. It's
but
through
are
the
these
ejection.
are these 6 highlights just stuff it found in July, or since it
No,
was up there?
These are since it was put on station and turned on till now.
Oh, okay.
These are
Gotcha.
cumulative discoveries. It unveiled hidden star-forming clusters in the Cat's Paw Nebula. Directly imaged two dying stars surrounded by a spiral-shaped cloud of dust.
Huh.
We can explore these more in a subsequent session. Scientists witnessed planets being born around a baby star 1,300 light years away. So, and the JWST completed 3 years of science operation on July 12. And I think only one of its mirror segments has been in any way damaged by a meteor.
Well,
collision.
3 years already?
yeah, I
Yeah.
know. Isn't that amazing?
That is amazing.
But
Yeah.
I think several segments have had hits, but only one had one that was considered of any significance.
It was launched Christmas Day 21, wasn't it?
Yeah.
It was
And
soon
how
after
long?
it was up, yeah.
How long did it take to get out there? 1,000,000 miles? A month?
No, it took a
They
while.
put it in orbit and then they gradually increased the orbit's apogee.
Well, why do you suppose none on these pictures you're showing here we don't have those incredible 5 early galaxies that's detected 300 million years after the Big Bang?
Because that was kind of a mistake, and a bunch of those, and it was 6, turned out to be accretion disks around supermassive black holes. So
Yeah.
they
Really?
weren't full galaxies. Yeah.
Yeah.
Well, that's big news. I didn't know that. That sounds like something in
Yeah,
the future we should talk
Well, I
about.
see we're going to go into each of these 6 things a little more deeply then.
Yeah, really. Fascinating, gentlemen. I love this stuff. I assume you guys do too, or you wouldn't be here after week after week after week.
This
What's
has
our
been a good
young
hour.
what's our young guy in India? What's his name? Something Delhi?
Astro Delhi.
Astro Delhi. I love that. Well, maybe he'll join us next week, and maybe the other two gentlemen, Bruce and Tom, will come back as well. Let's do it again. We're into the 5th year, and that was number 230. We'll do no, that was 231. Next week will be 232, and next Saturday night we're going to meet at dark at the museum after our afternoon meeting. Anybody want to join both things, please do. And how do we say goodbye in the Astro talk, Chuck, as you close out your emails?
Asta Nebula.
Hasta Nebula,
And
everybody.
does anyone remember and good night, Mrs. Calabash, wherever
Wherever
you
Yes.
you are.